So actually, this year the Moose strikes back again, the return, with Olivier and Masarah. Masarah, it's your first time here, right? Yeah. So welcome, and you have the floor.
Thank you. All right.
Welcome, and thank you for being at our presentation. Today we're going to talk about attacking Linux Moose 2.0, so the version 2 of Linux Moose, and which unraveled an ego market. So we firstly wanted to present ourselves. My name is Masarah Paquet Clouston. I'm a researcher at GoSecure Inc., which is a Montreal-based firm in cybersecurity. I'm also a master's student, just finishing now my master in criminology at University of Montreal. And I'm a treasurer for the NordSec conference, which we'll talk a little bit afterwards.
Yeah, so our accent is Canadian French, for those who are asking. Me, myself, I'm a security researcher at GoSecure, in charge of the team. I'm also doing executive position for the NordSec conference in CTF, and I'm going to just plug our conference quickly since it's in Montreal, and I think we are looking for speakers. And it's a nice place to be, so anyone here interested, it's a non-for-profit organization. We have a conference, Capture the Flag, and training. Awesome people and always looking for speakers. This is a picture of our hardware badge. I actually brought an extra one with me, so tomorrow if you see me and you want a hardware badge, I'll give it to you.
So just quickly, we wanted to go over the agenda today so you have an idea of what we're going to talk about. So we've done a research that try to sort of do a combination of technical and social analysis. So we'll firstly go on a quick Linux Moose recap. So be really, listen, because it goes really quickly. Then Olivier will explain how he built the honeypots environment for analysis and how we conducted the man-in-the-middle attack on the botnet. Once we did that, we accessed the decrypted traffic. So we sort of have a large conclusion of the whole analysis that we did over 5 characteristics in which we explain Linux Moose clever scheme. So we'll go over those 5 characteristics. And quickly, this is a joint research, and it's a good example of how we can do research that both is social and technical, but as well, it's corporate and academic. So it's both GoSecure, ESET, and University of Montreal that participated in the research. So I'll leave the floor for Olivier in the next 20 minutes.
All right, so Linux Moose, we had the fancy pictures of the Moose last year. So in a nutshell, it affects routers and Internet of Things, checkmark, I said IoT. In fact, what it affects is embedded Linux systems with a BusyBox userland. So anything like we saw IP cameras that are affected by that. We saw DVRs, routers, but it's mostly routers. These things are clearly targeted. It has a worm-like behavior. It spreads through Telnet credential brute force, which is like everyone knows about that now because of Mirai botnet, stuff like that. Its main payload, so it has several characteristics, but its main use is for a SOX v4, v5, and HTTP, HTTPS proxy service. It's really the core piece, as we've seen it deployed in honeypots. That is why it's existing. And it's used to proxy traffic to social media sites, which was kind of the thing we found odd. So after a long time of reverse engineering it, when we launched it into honeypots a year and a half ago, we were like, wow, why is it everything is going to social media sites? And also a lot of the traffic was HTTPS, and so it prevented us from really understanding what was going on here. All the gory details have already been released, so anyone curious about the technical details can go to the ESET paper or the past presentations. So at BotConf last year, we were at this point. So you see here is the screenshot of Wireshark. So we knew it was social media traffic because of the CN of certificates. And also we had some requests that were in clear text, like this Instagram request. We can see in number 2 that it's upgraded to HTTPS, so we actually only could gather a few usernames and not the actual modus operandi. So for spam detection purposes, fraud detection was not that useful. In number 1, we see the overhead of the SOX v4 protocol. So, and what we said last year was, good job, malware operator. We had this talk with the Fallout guy saying good job and bad job. We said, good job, malware operator. Most of your stuff is HTTPS, so we can't actually analyze what's going on. And so yeah, we decided how about we attack it, and this is the results that we are sharing today. Understanding the botnet in a larger context to have an understanding of the market they are in. Because in our mind, you know, the social media likes and follows and selling it is not new, but the fact that the botnet is doing it was new, and the fact that it's an undocumented market where we had no idea of the pricing and why the incentive to the criminals was worth sharing. So in order to catch Linux Moose version 2, we built a honeypot. We decided to go software-based instead of hardware because it was more flexible and we could deploy it worldwide. We have deployed it in Russia, Singapore, Brazil, several places in the world. We kind of expected traffic to be different based on the country, which didn't happen. We decided to go low interaction so that we could let it go, you know, without monitoring. And we decided to sideload an ARM virtual machine in order to, instead of running a fake client, we could run the real malware. So the architecture looks like this. We have on the left-hand side the infected host, so it's a QEMU system, an ARM Linux, the Debian ORL images, and we deployed Linux Moose on it. We put a man-in-the-middle proxy process in front. We had on the right-hand side the Cowrie honeypot, where we emulated a router userland, so the commands and the output of proc and stuff like that. We had a BusyBox emulated, and we enabled a telnet service on it. We use IP tables to route the traffic accordingly to what our intent was. And of course, we did the full packet capture meanwhile. So we chose Cowrie because it's written in Python, so it's easy to modify. It's easy to emulate a file system. You can actually, you know, untar binwalk router firmware and then extract the file system, and you have a tool in Cowrie that can emulate the whole file system in one command, which is pretty cool. And command output, it's actively maintained. The only problem was there was no telnet support for it. But since we're programmers, we figured we can do it. So we contributed telnet support to the Cowrie honeypot project last year. At first, we were kind of afraid that he will merge it, but in August, he actually merged it to the upstream project. So we're proud to say that GoSecure implemented the telnet support in Cowrie, and now I think it's a really valuable honeypot to study the future of the IoT or the DDoS botnet. So attacking Linux Moose, we wanted to take a look at the traffic. This is where our attack is. So we decided to go and understand the traffic more than by the certificate name, more than by the CN, because it limited what we could study. At first, we tried to do SSL strip on the Instagram traffic because we had the opportunity to do so, because it was in plain text at first. But this failed due to a redirection loop. They were always upgrading us to HTTPS, which meant that we weren't able to actually gather plain text traffic. So what we did instead is we figured we'll go full on man in the middle and expect and hope that they wouldn't detect us based on certificate errors. So in a nutshell, I'll explain quickly and visually what we did. So this is the normal operation of a proxy, of a SOX v4 proxy with HTTPS traffic. As you can see in purple, it's the HTTPS link. It's end-to-end, so it's encrypted and authenticated. So our attack is we introduced a component where we, using IP tables rules, rerouted the traffic to a process. And that process terminated the HTTPS connection, and we have to craft our own certificate authorities, meaning that the operators of the botnet would see certificate errors. But we figured that why not try it and see like if they actually validate it. And the thing is, the internet is so wild and there's so much stuff out there that we figured that they probably had a lot of errors and they just disabled checking. And I'm proud to say that we were lucky enough that it worked. So we needed to do a few hacks to avoid trapping the CNC traffic because the protocol is HTTP based. So this required kind of a little trick. And we crossed our fingers. But we, decided to still kind of help our luck here. So what we did is a bit of social engineering in the certificate authority. So it's really small, but the goal of this slide is to show you that we, for a certificate authority, decided to go with a security appliance certificate authority. So to mimic something that the botnet operators might have seen in the wild. Since we're lucky enough that the wireless is provided by Fortinet, and luckily the screenshot is about a FortiGuard appliance, so we emulated a Fortinet, a security product, thinking that the operators will be fooled by that. And at first it failed. We used the BetterCap first, and we had problems with HSTS bypass. It's a feature built into BetterCap that you can't disable. It uses a DNS trick to do so, and because in the SOX proxy you don't control the DNS is done outside of your SOX proxy, it didn't work. We had problems with that. We disabled it, so we patched the HSTS bypass out of the code. We rebuilt the gem, deployed it, but still we had problems where it would segfault after a few days. And we realized it generated no machine parsable logs, which is a problem when you want to monitor 10, 20 servers for over 9 months. So we tried man-in-the-middle proxy, and transparent proxy mode. It's been running for months, and it has a nice library to parse logs. It's all in Python, so it's pretty easy to use. Masarah was able to analyze the data by herself. Like she learned Python programming, and she was good. It was good, seriously, very good tool. I recommend it for anyone attacking botnets and HTTPS traffic. So it was a success. They disregarded the certificate errors generated by our fake certificate, and so it was good. We had access to the social media traffic inside of the botnet.
Okay.
So yeah, Sarah.
So where we're at now, right? We've got now several infected hosts actively used by operators. We've got HTTPS traffic in plain text. We've got CNC traffic. And while we were doing all that as well, we went into the seller's market and gathered a database with the prices and the quantities. So we've got all that data and we need to analyze it. So we sort of summarize our findings within 5 characteristics that sort of explain the whole scheme in which Linux Moose is involved in. We'll go through all of them one at once and then explain why we think that sort of creates the scheme. So Olivier, you still have to go for...
Yeah, I'm taking care of the first 2 pieces. So stealthy, we say it's stealthy mainly because they're really trying to avoid attention. One thing they do is they have no x86 version. So I've been running, collectors of and analyzing samples around embedded Linux systems for years. Most of the threats have an x86 version, like most except Linux Moose. And so for us, we think that this is to avoid collection and to avoid, the easier or the honeypots that are deployed without thinking about architecture-specific features. And so this, for them, is a way to avoid reverse engineering or easy reverse engineering if you want, no decompiler for MIPS. And I don't pay for the ARM version. Also, it does no ad fraud, DDoS, or spam. So nothing like obviously illegal or that Google is obviously against. So this is, again, it's doing something like that no one is interested in, which is, traffic, likes and follows on Instagram. And it has no persistent mechanism. The lack of persistence for us is explained by the fact that we saw updates in the code where they would change memory management. So we think that they crashed routers often. And so if your grandmother is infected and there is persistent and your router is crashing, every day, at some point she will get rid of it and buy a new one. So we think that they carefully avoided persistence in order to stay under the radar. So the router would crash, let's say, but then since it doesn't persist, it won't get reinfected until it is rescanned via telnet and weak credentials. So we think this is a way for them to just move from host to host and just take the low-hanging fruit IoT devices that are there, and they probably need a few thousand host botnet, and it's enough for them. So we say constantly adapting because after we released the ESET paper, they took a summer off and then they updated the malware to avoid the specific and low-hanging fruit IOCs that we released. So going through these, the IP address used to be hard-coded inside the binary. Now it's passed as an argument, meaning that you need to have a honeypot in order to have access to the argument. Otherwise, you won't have it only with the malware sample. But if you only run a honeypot and you don't know how to reverse engineer, you will still have a problem because the IP address is packed as an integer and it's XORed with a static value inside the binary. So you actually need both the binary and a honeypot system to be able to know the CNC. And the CNC was released in our latest paper. So if you want to go after it, you can, or help us do so. The proxy port change, this was really obvious, was the easiest snort rules and easy mitigation for ISPs. So we kind of figured it would change. So here's the old port and the new one, 20.012. The proxy service is only accessible from a specific list of IP, which we call a whitelist. And I'm pretty sure they call it also the whitelist because the parameter is WL. The whitelist is provided by the command and control server. And the existence of a whitelist prevents us from scanning the internet on that port to have an idea of the botnet size. We would need to have access to one of these IP addresses, which we are trying to do, and then scan the whole internet, and then we would have the exact botnet footprint, which we would love to do, but unfortunately, no one's collaborating with a shitty malware like that. With us tracking a shitty malware like that. They changed the bot enrollment process. So now, you actually need to infect from an infected host in order to receive proxy commands or proxy traffic at the victim side. So they could do it because the CNC server is involved in an infection. It's his who receives the proc architecture of the CPU and then decide what binary to send to the victim. So what we did is we use a debugger in order to throw a live infected host at our honeypot system. And this is how we've been able to successfully receive command. This took us a little while. We kind of haven't thought about it, and our honeypots were not successful. And then we kind of, went table rase, and we figured that and we thought about that it could be the case. And then once we started doing the debugging thing, it started to work. Our infection started to have better commands. They upgraded the protocol, so the old protocol was HTTP, but using binary data. So really easy, again, to fingerprint and really not normal traffic. As you can see, number one is the request and number two is the answer. The new protocol is wrapping it in real HTTP. So this is rather small, but you can see request and reply. So the way they're doing it is they are packing the old binary format inside an HTTP cookie. So the cookie field, so cookie for the client, set cookie for the server. They even use the default page of a web server. It works, as you can see in tree. So this means that at first when I found the CNC, I kind of didn't thought that it was the good one. I thought, oh, they probably cleaned that server because it's a default Apache page. But then after looking at the headers, I was like, oh, there are cookies and there shouldn't be cookies for stuff like that. So yeah, they do what we call bozo encoding. So they didn't use base64 to encode the binary data. They use a stupid custom thing that looks like that. So it was updated, so constantly adapting, but yet still the same. Going after weak telnet credentials using bots as proxy. And the whole idea is to have clean IP addresses so that they can go after social networks and have IP addresses that are DSL lines, cable lines, and consumer IP addresses. So this, I think, is what they leverage through this IoT botnet. And also be maybe more stable than if you infect a PC where you get detected and you draw more attention. And it still targets social network. And on that, Masarah is going to talk about what it's doing.
Fun time. Okay, so we also know that social media fraud doesn't create any direct victims. What's social media fraud? We came up with that definition that says the process of creating false endorsement of social networks accounts in order to enhance a user's popularity and visibility. And mostly it is just creating fake accounts, going onto social networks and doing likes and follows. Through Linux Most traffic, what we could see in our honeypots is that most of the requests were sent towards Instagram. So our botnet was focusing on that social network. at 86%. We had a bit of Twitter as well, but it was often flagged as spam really quickly. And a bit of Periscope, Flippergram, and Kiwi, which is, I don't know if you know those social networks, they're not really well known. But we'll talk a bit more about them later. We focused on the Instagram social network just because it's 86% of the traffic, right? And we look at what it does on Instagram. And what we found is that most of its activities is a walkthrough to either perform a follow or a like. So what we found is that 13% of the requests are actually billing things, like things that the botnet can bill. And the rest is just the botnet trying to look human. So we found various modus operandi, we say, that the operators would sort of try to look like a human. What we found is, for example, he would go and it's logging in its fake account, and then go in its inbox and then go and see potential recipients. It would go on its personal timeline and do all those requests. So it would then create a following without being flagged as a spam by Instagram, because if it was only, it's quite obvious, if it was only doing following, then he would be like flagged right away. But what we find is that's really successful, right? Because in 89% of the cases, Linux Moose actually could do a follow successfully without being flagged as spam by Instagram. In 11% of the cases, we found that Instagram was actually flagging, saying, you're a spam, you're a bot. If you are not, please contact us. And we have no idea how they actually sort of managed to flag 11% of them. But you know what? What's interesting about that is that follows don't last. So Linux Moose puts a lot of emphasis into doing those follows that are actually not flagged, but it doesn't put any efforts into the botnet accounts, the fake accounts. So what it does is, what we found is that most of the fake accounts were looking like robots. So they had like fake pictures, not fake pictures, but buildings, plans, or really sort of boring pictures, and it had no followers, and it was following lots of people, no descriptions. And through our 6 months analysis, we found that 72% of our fake accounts that went through our honeypots were suspended by Instagram. And what does this mean, right? Because it means that buyers are getting ripped off because they're buying their follows and they're getting them, but within 6 months, they're going to lose them all and you'll have to buy again. But talking about the buyers, who are they, right? Who are those people that are actually feeding the botnet? Well, what we did is through the traffic, we could determine potential buyers by going into, looking at the traffic and going into the follows, the profiles on which the follows were performed by Linux Moose. So we took all active profiles that were either business or individuals that had lots of followers by the time the follow was created and no reaction in the pictures that were posted. So for example, if you've got 150,000 followers, but you posted pictures and 26 people react, then it probably means that a great percentage of your followers are fake. So we sort of determine 3 big categories that are overlapping, just showing who are the buyers and who are those buying social media fraud. The first category is business-related accounts. Here we've got an electronic cigarette shop with 17,000 followers. It's actually, like, we blurred it for ethical reason, but you could actually go into the websites and then go and buy electronic cigarettes. I'm not sure they're going to be shipped to you, but still. So we found lots of business-related accounts that were either online, so solely online and maybe a scam, and some of them as well that were in like small businesses that don't have money to actually buy large marketing departments. So, for example, the pizza shop in Kuwait or a restaurant in Brazil. We also found lots of business-related accounts, but that were centered around the individual, and we're going to build towards the ego market here, right? So here we've got an example of a guy who's got 1 million followers, and he is a web designer looking for projects, luxurious only. And what is funny is that it links to its website and to the fact that he's doing that, but most of his profile pictures are just focused on him and his wealth, right? We've got a guy on a boat, a guy smoking shisha with his Mac, with his nice car, his cute dogs, and his watches. So, and we found lots of them, like lots of tattooists, photographers, anything that could sort of be a business, but could be centered around an individual. And finally, we found lots of aspiring celebrities. So anything blogger, anyone that could actually want to have more business by being popular for their own, what they're doing. So we've got singers, bloggers, and the like. So those are sort of the three large categories. We found as well lots of that, which I had to blur lots of it because it's mostly skin, yeah. So those are people that actually, they buy social media fraud, but they're not business, they don't do it for themselves. Well, they may be business because there's like some bodybuilders here, but in the end, you don't really know. It's, yeah, my favorite was always the one here with million followers as well, which is like chilling out with his Mac in the water or with his Kalashnikov and a girl. You're always like, you're really popular, good. So yeah. So is this an ego market? Like we came out with that name and well, that's pretty much what we saw from the buyers. Here we've put two pictures, one of Selena Gomez taking a picture of herself with this guy being really mad. And then there's our Canadian Prime Minister here who's really known for taking pictures of himself all the time. So just to come back, no direct victims. Well, social media fraud doesn't create any direct victims, just like ransomware, right? The only victims that we could find were those that get fooled by the false popularity. So advertisement companies that actually pay those people to advertise for them, but they're not going to have the visibility that they actually paid for, but who really cares? And the people are, sorry, the botnet master or the people behind that, they're making criminal money by having a botnet, but they're actually selling to common people the service that they're providing, right? So they're charging legitimate credit cards, and they're probably doing their tax returns just saying that they're doing social marketing, right? Who wouldn't believe that? You say, I'm doing social media marketing, and if you don't get audited, then you're fine. So next characteristics, hiding in plain sight. That's because we went through the seller's market, and probably everyone sort of knew that you could buy fake followers online on really easily accessible websites, like this one here. We found like hundred thousands of websites and social media fraud being sold on all sorts of social networks from Twitter, Facebook, Google+, etc. And what's interesting is that it's easily accessible through search engines. So it's like looking at the buyers, you would expect that you could easily go through Google and just buy that, right? And then we wanted to give you an example of the price bundles. So for example, here you get from 100 followers to 50,000 followers, and if you want to buy 5,000, and then it's $40. And with the database that we created, at first we didn't know that Linux Moose was focusing most solely on Instagram. So we sort of built that, and we could just give you an overview of the prices and know that Instagram is cheaper and LinkedIn is much more expensive. And you've got Facebook in the middle. What's interesting about the prices is that for all of them, what we found is it's really there's a lot of variation. So if you could buy 10,000 followers for $2, or you could buy 10,000 followers for $2,000, right? And usually in economics, we say that if the prices are really, really close to each other, it's because it's really competitive if everyone's trying to grab the market. But here what we see is probably not that it's not competitive, much more than it's probably an immature market. So people don't know the worth of their service. So they're either overpricing or undercharging. And buyers don't know exactly what's the worth of it either. So what they do is they just try to gauge which one they could buy, and they're not going to be less ripped off, right? So here's a little story. Because we've been through all those websites and gathered data on the prices and the quantities, but we really wanted to find that website that was actually selling Linux Moose service, right? So we could find the end where the prices were. So we found a seller that sold Periscope, Flippergram, and Kiwi social network services, which, if you don't know, Periscope is a live streaming social network. Flippergram is videos, and Kiwi is asking questions. And he sold as well Instagram. So I went to see Olivier, and I was like, that could actually be our seller. It could be Linux Moose. So we created a fake account and decided to buy fake followers from them and see if if the fake account we created could actually go through our traffic and our honeypots. That would confirm that that's actually related to Linux Moose, right? So I created a fake account called Beautiful Bird, and yeah, and about 6,000 followers. And you can see that they were provided throughout the weekend. But then just like the day afterwards, I lost lots of them. And that was a good opportunity for me to contact them, right? Because it was related to an email address. So I contacted them first saying, hey, about 6,000 followers from your website last week. And at that time, I had lost 500 followers, but I lost more during the day. So I asked, can you provide them to me again? And I started a little story about a contest in winter photography. And he replied really quickly, sure, adding. And as you can see, I got 8,000 followers, so everything was fine. My fake account was really, really, really popular, right? Which is good. But then I lost again 1,100 followers like a few days afterwards. So I wrote to him again because we wanted to see if my profile would end up in the traffic. So as soon as I lose them, I'd write to him, like, push me up again. So he replied, I'm adding. Well, followers are not forever, but I'm adding them when you ask for. Really bad English written, but still. So I was like, fair enough. Every time I'm losing followers, I can actually ask you more, and my probability that if it's the good person, we'll see it. And then I lost so many followers, no replies. Lost so many followers, no replies. So he ended up just stopping replying to me. And now my fake account has 1,100 followers, and those are my pictures, and no one reacts to them. So, yeah. That makes me really sad. But it ended up in our traffic. So we actually found that there's not a lot of research that starts from a malware binary and can actually find from where the service is sold and what are the prices. It ended up in we were about 80% sure that that's actually related to Linux moves. So yeah. And the last characteristics that we wanted to talk about is large potential profitability. And that's because we had the prices, we knew how many follows the botnet performed on average, right? So what we did is we took an average, we took our honeypots and looked at the number of follows that were performed per month on Instagram. And then we took an average of the prices and try to estimate how much every bot would make per month, right? So if all follows were monetized only on Instagram, Linux Moose would make $13 per month per bot on average, which is a lot. Thinking that renting our servers just to run the honeypots cost us $10, so that's $3 profit here. But yeah, but in the end, you need to monetize all your follows. So what we did here is just for fun, looking at the potential revenue of Linux Moose according to the number of bots that would actually exist. Sorry. So if you look at it, you see that there's a large potential revenue. If Linux Moose had 3,000 bots, he could actually make $400,000 per month, which is a lot. Okay, let's say we know that all follows are not monetized, right? Because we saw that he actually gave me more while I was complaining. So let's say he monetizes half of it. Then we see that with 30,000 bots, he could actually make, on average, $200,000, which is still quite a lot. So what we can come up from that, mostly, because we don't know how many bots Linux Moose has, is that it's actually sitting on a pot of gold. But there's the questions of how many follows are monetized, but there's also a question of how many administrators there's behind Linux Moose, because that we don't know either. What we know so far, and we're going to continue our research, is we know that there's 7 IP addresses that Olivier mentioned that actually you can push requests through the bots. So we know as well that looking at the profiles, some of them had descriptions and 3 languages were used, mostly Dutch, English, and Spanish. And we found so far related to that email address, 7 web interfaces. So we'll continue our research because we're probably thinking that he's within a reseller model. So having lots of web interfaces where they're actually pushing him, saying, oh, put more followers on that profile, and he's just doing it. So yeah, that's pretty much what we found about Linux Moose. We know that it's stealthy because it has no x86 variants and it's running on embedded system. We know it's constantly adapting because we've seen from the ESET research report that it actually changed lots of features. We know that what it does doesn't create any direct victims, and it's so peculiar that we can't, no law enforcement agents wants to take down the botnet or take time for that. We know it's hiding in plain sight because it's selling services not on underground forums, but on clear web, just through an easily search engine. And we know as well that it has a large potential profitability just because there's lots of money to make from having a botnet and creating fake follows. So that, in the end, sort of made us think that Linux Moose is sort of involved in a really clever scheme that is sort of a criminal interstice, where he's running a botnet but not attracting any attention and not actually, well, we're actually wondering, because we would like to find the guy or those people and see if they're actually like driving BMWs and living in really big houses and stuff like that, to see if that's really possible. So it sort of made us think that it could be sort of a perfect internet crime where you are involved in botnet but making lots of money without attention, which is, it's cool. It's a cool conclusion, except that we had to go through all this for like 6 months. And that made me, while I was working and clients were coming in and they could see my computer, I was like, yeah, that's the research, that's research. And it's so perfect. Linux Most is so perfect that throughout those 6 months, we could not raise any interest from law enforcement or hosting providers. And we're sort of calling out today, asking if anyone would be interested into collaborating with us so we could actually attack the CNC server and access how many, do sinkholing and access how many bots are actually owned or infected by Linux Moose. And we lost a bit faith in humanity because, yeah, ego market doesn't make you believe in humanity anymore. Until we saw this, right? That's a profile of dogs with more money than you. If you want to hate them, but they're just so damn cute, so. Well, so that's it. Thank you very much. If you've got any questions, please come.
We have IOCs for the threat online on the ESET's GitHub page also, and the paper and blog, and the paper will be released with the BotConf papers.
Questions?
Hi. Did you also try to contact the social media websites themselves if they wanted to take any action?
We did a year and a half ago, so not for the version 2. In version 1 we did, and we got absolutely no response. Like they didn't, but okay, so I didn't have any unencrypted traffic, I only had encrypted traffic. So yeah, absolutely nothing was going on from them. And for this time around, I guess we ran out of time, or I was jaded and I didn't want to get in touch. But at this point, now that we've released the research and I'm less worried about burning my honeypot IP addresses, we can. So yeah, I have a ton of PCAP and a ton of clear text logs to share if anyone's interested. Facebook, Instagram.
Thank you.
Oh, and just want to say as well, like, for them having more followers and more fake accounts just makes them having more. Is it? No, oh, sorry. So, for example, if like Instagram lately just said, oh, we've got 500 million people into, like, we're the largest social networks, and that's really good for their stakes. So, yeah.
I have a question. Do you know why an account of LinkedIn is more expensive than Instagram or Facebook?
Well, I've got a hypothesis. Like, yeah. I think Instagram is probably, it's easier for the botnet to actually create fake accounts on Instagram. I think there may be more demand as well. No, sorry, more supply. And I think LinkedIn is, yeah, like, I'm not on LinkedIn, unfortunately, so far yet. But, but I know that getting followers must be hard because they're actually clustering people, and you can't have, like, having 500,000 followers is probably.
It's a structure of social network,
Yeah, I think so.
And the probably team of Defear to take down bad accounts, I think.
LinkedIn also leads you to a job, so maybe, you pay for it because you see that you make money eventually.
Thank you.
Just to follow up what was asked before about contacting the social media providers, I did some part-time research a few years ago into fake Twitter accounts, and Twitter was actually interested in that. But also, if you have, in this case, with Twitter, if I had a few accounts, then I could, just from looking at the Twitter profiles, I could analyze and find similar accounts. So maybe Instagram, if they had these 1,000 accounts that are fake, from their vantage point, they could probably see accounts that are similar, so similar behavior, and they might be able to take down hundreds of thousands of accounts maybe created by different botnets or different ways. So I am more positive that they do probably care to some extent, especially if you give them like, here's a list of 1,000 accounts, and maybe you can find similar ones.
So we think they actually do a good job of that because, as she shared, 72% of the account were eventually flagged as spam. So, but we think they operate in sweeps. So they actually probably have some, let's say the buzzword, machine learning, and they figure out clusters of accounts that are related, and then they maybe do timeline analysis and stuff. But they actually are pretty successful, and maybe I don't think that our traffic will be that valuable. But as I said, at this point, I guess I should get in touch, and I'm just being rude of not doing it. So yeah, good point, Martin.
Any more questions? 4, 1, 2. Over there.
I'm wondering why you had to set up a man-in-the-middle HTTPS instead of hooking the processes in order to get an encrypted traffic.
So because it's a proxy, there's no way to have the actual HTTP. It's not a browser in the malware. It's just traffic is going through it. So there's no way of having it in clear text.
Okay, thanks.
Last question?
The proxy architecture is actually very nice because it means that the malware sample is really simple. It's like one C function that performs the SOX proxying. And so the intelligent or like when you look only at the malware sample, you don't understand the intent of the operation. You actually need honeypots and to gather the stuff. So I think a lot of the crimeware is putting less and less intent in the binary files, and I think this is the criminals that are adapting. We think this botnet is a lot about adaptation. Staying under the radar, moving to a new legitimate criminal model where they can charge legitimate credit cards. So it's really interesting to see how they keep being a step ahead.
Okay. Thank you.
Thank you so much.